Okay, so given the following equation, we are trying to figure out if we have 25.4 grams of aluminum trioxide and 10.2 grams of iron, how many grams of iron oxide product we produce. Then we're going to determine the number of grams of excess reagent left over after the reaction. So there's a few things we're doing here. First, we're determining exactly how many grams of Fe3O4 is produced by determining the limiting reagent. Then we're going to figure out how much is left over of the reactant that is not limited. So if we start out with 25.4 grams of Al2O3, let's convert it into this product because that's the product that's being asked for. So first we need to convert to moles using the molar mass of aluminum trioxide. So for every 1 mole, we have to figure out how much does 1 mole of aluminum trioxide weigh. So 2, 3 times the molar weight of aluminum and the molar weight of oxygen. Okay, so for there are 26.98 grams for every mole of aluminum and about 16.00 grams for every mole of oxygen. So when we do that math, we're going to see that 3 times 16 is equal to 48, and 2 times 26.98 is equal to 53.96, I'm going to say. Something like that. I think I'm close. So 101.96, is that about right? Cool. I'm going to say, I'm going to round that up to 102.00. So we're going to call this 102.00 grams, which is going to equal, grams are going to cancel out. We get 25.4 over 102 moles of Al2O3. And we do the math for that one. We get 25.4 divided by 102 gives you 0.249 moles of Al2O3. Cool. Let's do the same thing with iron. We have 10.2 grams of Fe times for every 1 mole of Fe. 1 mole is equivalent to 55.85 grams. And so when we do that math, 10.2 divided by 55.85, we get 0.182 moles of Fe. So now that we have the moles that we can start with, this process is a lot easier. So let's go back and revisit our original equation. Here, we now realize we're going to have to balance the equation. So let's go ahead and do that at the top. So over here we have 3 iron atoms. So we're going to need 3 molar equivalents of iron, no matter what, to balance that out. And over here we have 2, and no matter what, have to balance that out with 2. That's the first step. The next thing I would do, start to figure out how many I have on each side, Al, O, and Fe. I now have 2 Al on the left side, 3 oxygen, 3 iron, and on the right side I have 3, 4, and 2. So we're going to have to balance the oxygens. I know that the only way a 3 and a 4 are going to be even is if we multiply them by each other. So I'm going to put a 4 in front of this one and a 3 over here. And that's going to screw things up a little bit, but that's okay. So now let's revisit how many atoms are on each side. We have 8 iron, or 8 aluminum on this side. We have 12 oxygen, and 3 iron. On the right side we have 9, 12, and 2. Well, this is an easy fix. Let's come in here, and we'll put a 9 in front of the iron, and that should balance that out. and we'll put an 8 in front of the aluminum, and that should balance that out. So now that we have balanced our chemical equation, let's go ahead and find out how many grams of Fe3O4 are produced by determining the limiting reactant. So here, we're going to be looking for limiting reactant. So we start with 0.249 moles of Al2O3 times the molar ratio between Al2O3 of 4 and 3, okay? For every 3 moles of Fe3O4, we have 4 moles of Al2O3. And that's going to give us, we'll do that math in a second. And the other equation we're looking at for iron is 0.182 moles of Fe times 3 moles of Fe3O4 and 9 moles of iron. Cool? So if we do that math, we'll see that the limiting reactants we end up with, we have 0.249 times 3 divided by 4, and we get 0.18675 moles of Fe3O4. And I can already tell you that the other one is going to be the limiting reactant, because 0.182 times 3 divided by 9 is going to give you 0.0607 moles of Fe3O4. So iron is our limiting reactant. Okay, I'm going to stop for a second. So now that I've determined the limiting reactant, I know that iron is going to limit the amount of Fe3O4 that's produced. But we want to figure out exactly how much Fe3O4 is going to be produced anyway, so let's go ahead and do that. 0.0607 moles of Fe3O4 times, for every 1 mole, we want to figure out how many grams the molar weight of Fe3O4. You're going to get 16.00, and Fe is 55.85. So when you do that math, you're going to end up with, let's see, 3 times 55.85, 167.55, and 64.00. Add them together, you'll get 131.55 grams of Fe3O4. And that's the amount we're going to produce. Because we know this one's a limiting reactant, that iron is a limiting reactant, we can't produce any more than the maximum value of Fe3O4 that iron can produce. So this is all we have to do to get the answer for part A. Now to determine the answer for part B, we have to determine the number of grams of excess reagent left over. To do that, we need to take the moles that we've calculated and turn them back into grams right here. Oh, well, of grams, here, 1 second. Thank you. Yeah, let me correct that error. That's not a 1, that's a 2. Oop. Beautiful. But we know how many moles of triiron quadroxide or whatever, tetroxide, that we produced. So, oh, sorry, that was just the molar mass. I apologize. I was not thinking. That goes in right there. That is not how many grams. That's the grams for every 1 mole. We need to do that math to determine how many grams are created, which is 0.0607 times 231.55. That's going to equal a total of 14.055 grams of Fe3O4. And that is your answer for A. I knew I was messing something up. There you go. Does that make more sense? Okay. Now, that's the answer for A. Now let's go look at B. And for B, we have to take the moles that we started with, or that we determined our limiting reactant produces. of Fe3O4 and figure out how much of the actual excess reagent, which is aluminum trioxide, are used up. So we're going to use this same molar ratio times for every 3 moles of Fe3O4, we have 4 moles of aluminum trioxide. And we're going to say 0.0607 times 4 divided by 3, which gives us 0.0809 moles of Al2O3 times for every 1 mole. We said the molar mass was up here 101.96 or 102. Let's just go with 102 for now, for the sake of brevity. And we get 8.255 grams of Al2O3. Now we started with 25.4 grams of Al2O3. So 25.4 minus 8.255 is going to be equal to 25.4 minus 8.255 equals 17.145 grams of excess reagent left over. And that is the answer to B.